what should I do? Yeah, come on. Any idea here? So what is it that I have to do? So now basically I have to prove that this matrix, this as a function. So this I can ignore now, right? So we can basically can ignore this, right? Because it's independent of t. So I take a convex function, add a constant to it, it will still be convex, right? So it doesn't matter. Now as a function of t, I have to prove that this is invertible, right? Sorry, it's convex, right? Now suppose, for example, this is suppose, okay? You should verify and tell me whether this suppose is true in the next class. If suppose is not true, then we need to think. But suppose I plus x whole inverse y, the product has an eigenvalue decomposition. When I say has an eigenvalue decomposition, I mean u lambda u transpose kind of a decomposition. So if it has an eigenvalue decomposition, what do you get? The first term as is, right, plus log of determinant of identity plus t times. I can write this as something like v. What happened? V sigma v transpose, right? You agree? Now the usual stuff, right? Plus log of determinant of identity plus, well, now what happens? I can pull this v out here, this v transpose here. Do you agree? V transpose is anyway identity, so I can write this as V transpose. So I pull the one V to the left and the other V to the V transpose to the right. So what do I get? Log of, why is this true? Because determinant of V times something diagonal times V transpose. So V transpose, determinant of AB is determinant of BN. So V transpose will go to the other side and it cancels, right? We saw that as an exercise when we studied linear algebra. So V transpose will be identity. What we get is determinant of identity plus T times sigma. Now what is the next step? Well, identity plus T times sigma is basically diagonal, right? So determinant of the diagonal is product. So log of the product is sum. Let's say it's an n-dimensional or n cross n matrix, it will be log of 1 plus t times lambda. Okay. Now what is log of 1 plus t lambda? Well, I think I made a mistake. Then the function is, I'll put a question mark. Let's see what the function is. Okay, so sorry about that. It's not convex. We'll see what this is. What is log of 1 plus t lambda? What kind of a function is that? Can you please check quickly and tell me? Lambda is or positive? Okay, so this is, what kind of a function is lambda log of 1 plus ax as a function of x? How do you check whether it's convex or not? What do you do first thing? Well, you can take the second derivative, right, and see if it's positive, non-negative. So how do you prove that? How do you see that? You take the first derivative. First derivative is 1 over 1 plus t lambda I. What is the second derivative? Minus something over 1 plus lambda I ti whole square, lambda I t whole square. So it's negative, right? So that means minus of this is convex. So what is log of 1 plus t lambda I? Concave. So that means for each I, this function is concave. What is if you have f1 is concave, f2 is or let's say f1 is convex, f2 is convex. What can you say about f1 plus f2? Convex, right? Why is that? Is that true? Did we verify that? No? Okay, let's verify that. Okay, so if f1 and f2, or for a change I'll say concave, then f1 plus f2 is also concave. I want you to verify. It's a trivial exercise, but